To prove the product rule, we're going to use the definition of derivative. So if we have two functions being multiplied together, f of x times g of x, the definition of derivative would say the limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. Okay, in order to proceed with the definition of derivative, we have to do a little trick, algebraic trick. We are going to basically add 0 to the numerator, but 0 is going to look like f of x plus h times g of x. And the positive and negative of that. So I'm going to add the negative of that and then the positive of that to the numerator, and I'm going to insert it right in between these two terms. So here we go. F of x plus h times g of x plus h. I'm going to insert my 0 minus f of x plus h times g of x plus f of x plus h times g of x minus f of x times g of x all over h. We're going to do a little factoring of these terms in the numerator. So I'm going to just highlight the terms. So the first two terms we're going to factor, and the second two terms we're going to factor. So we're going to have the limit as h approaches 0. Factoring the first two terms, we'll pull out an f of x plus h. Left behind is g of x plus h minus g of x. Factoring the second two terms, we'll pull out a g of x. And the factor remaining is f of x plus h minus f of x. Now, all of this is over h, okay? But I'm going to save some space by writing, and I just want to do a little aside for a second. If I said 2 plus 7 all over 5, I could rewrite that as 2 over 5 plus 7 over 5. Okay? Just using the properties of fractions. So what I'm going to do is I'm going to say I have two fractions I'm adding together. And the first fraction is here. And the second fraction is here. Okay, so I have g of x, I have f of x plus h times this fraction g of x plus h minus g of x over h. The second fraction is g of x times f of x plus h minus f of x all over h. Okay, so if you recall the rules of limits, when you have the limit of a product, you can take the product of their limits. So limit of product equals the product of the limits. Okay, so what I'm going to do is I'm going to take the limit of this first term, the limit of f of x plus h as h goes to 0 will be f of x the limit of g of x plus h minus g of x over h. Let me write that for you just so you can kind of see. Well, that looks a lot like the definition of derivative. So for example, up here in the corner, we have the definition of derivative, f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. All right, so what we're looking at here is the limit of g of x plus h minus g of x over h as h approaches 0, and that is g prime of x. Okay, taking a look at the limit of the second term here, g of x times f of x plus h minus f of x all over h. Well, the limit of g of x as h approaches 0 is g of x. The limit of f of x plus h minus f of x all over h as h approaches 0 is f prime of x. So what we have found is the definition of derivative produces this result, f times g prime plus g times f prime, for the derivative of the product, f of x times g of x. Okay, so we're going to use the product rule. We won't make you derive it again, but we're going to use the product rule to find the derivative of a function called h of x, which consists of two factors, x cubed plus 1 and 2 to the x. Okay, so let's just recall, what is the derivative of x cubed plus 1? That's just a power rule. So it's 3x squared, and the derivative of 1 is 0, so 3x squared. What's the derivative of 2 to the x? Recall from our previous lesson, the derivative of an exponential is the natural log of 2 times 2 to the x. Okay, so in order to use the product rule, let's just remember what that is. If h of x is equal to f of x times g of x, then h prime of x is equal to f of x times g prime of x plus f prime of x times g of x. Again, it doesn't matter what order. So if you said g prime times f plus g times f prime, however you say it, you know the rules of addition and products. Order doesn't matter. Okay, so this function will be my f of x. This function will be my g of x. So the derivative will be x cubed plus 1, which is f of x, times g prime, which is the natural log of 2, times 2 to the x, plus g times f prime, so g is 2 to the x, times f prime, which is 3x squared. Now for future reference, it would be good to factor common terms. So I'm going to factor the 2 to the x, and then write the natural log of 2 times x squared, x cubed plus 1 plus 3x squared. And for purposes right now, I'm not going to simplify that any further. but later on, simplifying it to factored form would be very helpful. Let's see if we can do one more example, maybe two, before we end the video. So here we have f of x equals x times e to the x. All right, so I'm going to think of our function as the product of two functions, x and e to the x. All right, what is the derivative of x with respect to x? It is 1. What's the derivative of e to the x with respect to x? It is e to the x. All right, so f prime of x, I could write it this way, the first times the second derivative, second function's derivative, plus the second times the derivative of the first. Okay? So my first function is x, my second function is e to the x, and its derivative is e to the x. Plus my second function, which is e to the x, times the derivative of my first function, which is 1. So the derivative, f prime of x, is equal to x times e to the x plus e to the x. Again, I'm going to factor e to the x and call this e to the x times x plus 1. Okay, one last practice. It says to find the derivative of f of t equals the square root of t times 1 minus t two different ways. Okay, well, one way would be to use the product rule. So let's do that. My first function, the square root of t, with respect to t, its derivative would be 1 over 2 the square root of t. My second function, 1 minus t, its derivative with respect to t is negative 1. Okay, so f prime of t, again, will be the first function times the derivative of the second function plus the second function times the derivative of the first function. All right, so working that out, my first function is the square root of t times the derivative of my second function, which is negative 1, plus the second function, which is 1 minus t, times the derivative of the first function, which is 1 over 2 the square root of t. Let's simplify a little bit. We're going to get negative square root of t plus 1 minus t over 2 the square root of t. All right. I am going to choose to add these fractions together, getting a common denominator. Okay, so my common denominator would be 2 the square root of t, which means I need that factor multiplied by the numerator of the first fraction. So that's going to produce just a negative 2t. Adding my 1 minus t. Let's simplify. That's going to be negative 3t plus 1 over 2 the square root of t. I certainly hope I did that right, but let's check this real quick. If I just distribute and call this the square root of t minus t to the 3 halves, this is still my f of t function. Let's take its derivative, f prime of t, using the product rule, 1 over 2 the square root of t minus 3 halves t to the 1 half. Sorry, I did that in the wrong spot. T to the 1 half. All right, and if we get a common denominator, we're going to put a factor of square root of t here, so it's 1 minus 3t over 2 square root of t. Done.